So welcome everybody. In the text chat, I've put some resources that we'll be using as part of the workshop. There's a copy of the presentation, which has some notes underneath, which you can laugh at as we go along. And you're going to be doing an exercise while we're during the course of the workshop, and there's a worksheet for you to work from so that you can keep copies of what we're talking about. And though as part of those exercises, you're probably going to need to access the property hierarchy and the class hierarchy. So I've made some little PDFs of those, although at the top of the list, you can see the link to the current version of the standard, which, as George mentioned in his introduction to the SIG earlier on, will be replaced with version 7.1 probably in the new year. But there aren't too many differences. Nothing that will significantly change what we're talking about today. So those of you who have the joy of microphones, please turn them off while I'm talking, because otherwise we tend to get a lot of feedback and chatter. And if you want to ask a question, open them up and speak then, and that'll be fine. I'll listen for you asking questions, or if you don't feel like asking a question over the airwaves, then stick it in the text chat, and I've got that open, so it should catch my attention as things go by, because I've got that in the center of my screen. So hopefully I'll notice if you put a text chat in. Okay, so I guess we're ready to kick off. It's a few minutes past. We'll let in some latecomers and we'll get started. So my name's Stead. I'm a member of the CRM-SIG. I have been for a few years now, since it started, I think. And I'm going to talk to you about really some principles of the way we've built the CRM over the last 20 years or so. And so this is just a quick introduction. This is the agenda. I'm going to give you this introduction, then I'll give you some background to the problem. We'll look at the design fundamentals, the building blocks of the decisions we made about the way we wanted to build the standard. Then we'll talk about the supported functionality with a little example of some of the interesting things that you can do. And then finally, we'll start to talk about some of the detail in the CRM, and we'll do as much of that as we can before we run out of time. Obviously, there's a lot of detail in the CRM if we really want to talk about every possible combination of things. And that would take rather longer than 2 hours. And normally I spend about 4 hours on this introductory workshop. So this is going to be a little faster than normal. So if you do have questions, if I've said something that was completely incomprehensible, stick your hand, say something, put something in the text chat immediately. Don't wait, because you'll never remember what it is that you wanted to ask me for later on. So what I want you to be able to do at the end of this workshop is distinguish between classes and properties just by looking at their name. Identify the class hierarchy that a particular class belongs to, or the part of the property hierarchy that a particular property belongs to, so you can understand the structural elements of the standard. And then I want you to be able to utilize the concept of multiple instantiation. If you don't know what that is yet, you will do by the end of this couple of hours, and you'll be able to deploy it as part of the way you design systems and utilize the CRM in your own work. So let us move on to the background. So the problem that we face with most cultural heritage documentation systems is, how do we cope with the fact that it's such a broad church? There's so many different things that we're interested in recording and having in our documentation systems. So we don't just want the collection descriptions of lots of different domains, so art, natural history, archaeology, anthropology, natural history, and so on. We've also got things like archives and literature, which give us treaties and letters and poems and all sorts of fun documentation and documents to play with. We've got the records that we generate as part of our administration, preservation and conservation of the objects in our care. And we study them. You know, we want to learn things. We want to make statements about them. So we investigate these wonderful sets of objects that we have, and we offer interpretation for our peers and for a lay public to consume. So we've got all sorts of information that we're generating through those acts of scholarship and observation. And then finally, we start disseminating information. So we have presentations, we create exhibitions, we have teaching materials that we want to gift people with some kind of knowledge, perhaps. And we publish, and we want to be able to incorporate the information that we publish into our documentation systems. Now, the problem is with all of these different things, how could you possibly make a documentation standard which will be able to deal with all of the aspects? Yeah? Each of these aspects has its own approach. It has its own requirements, its own needs, its own target audiences. And consequently, we're going to have lots of different data structures which support all of these different environments. And so when we look at all of these different elements, all these different data schemas that we have, we find that there are common elements, things that overlap. And it's those things that we want to be able to describe consistently across all organizations, or all different subdisciplines, so that we can integrate them together and make it easier to navigate through this rich information source that is everybody's data together. Now, if we try to build a single schema to hold all of this, it would be massive because of all the special edge cases, all of the special things that people want to do. And consequently, we've tried it and it doesn't work. We've had a couple of shots at it back in the 90s when that was the way forward, or that's what we thought was the way forward. And it produced some absolutely horrendously complicated data structures, which nobody could actually implement. And people tried. There were big projects around the world. In the UK, there was a huge project which desperately tried to implement a massive data standard. And it failed because people couldn't remember what the data standard was. By the time you started at one end of an entity relationship diagram and got to the other end, you'd forgotten what the first end was about. They were simply huge. So we decided that what we needed to do was move our thinking forward in a new way and look at how we would integrate all of this data using a different paradigm rather than just constructing a huge data structure, which would, by its very nature, become a tool for fossilizing the discipline. We'd lose the ability to innovate because we'd have ended up spending so much effort making this massive data structure that nobody would ever want to change it. And consequently, we'd never be able to ask any new questions or record any new types of data. It would be a disaster. So while we were thinking about that, we also thought about what is it that we're actually interested in recording. And we reached the conclusion that what we're interested in is understanding the history of things. And history is made up of relationships between people, events, and things, the objects, or physical objects, and also the immaterial objects, the ideas, the poetry, the concepts that we're used to developing as a species. So how do we express this linking of objects of different types, of people and things together? And that's what drove us into creating the CRM as it exists now. So to give us some background then, the CRM is a collaboration. It lives inside CIDOC, hosted by, obviously, CIDOC's part of ICOM. This is an international hosting arena. It's a place where we could come to work which had the right outlook on the kinds of problems that we wanted to tackle. We've ended up with an ontology with the core ontology is 81 classes and 161 properties, which is, that sounds like quite a lot, doesn't it? No, it isn't. That's incredibly compact. Some of the chemistry ontologies have multiple thousands of classes and tens of thousands of properties. 81 classes and 161 properties, after a little bit of practice, you can remember nearly all of it. It's actually at a human scale. It works. And it's the opposite of everything that's been learned about all of the other computer science attempts at building ontologies for specific domains. They've tended to go incredibly wide, incredibly quickly, and be very, very shallow. They only deal with a tiny aspect of a domain and produce these massive ontologies. Whereas we've done the reverse. We've taken an absolutely massive domain and condensed it down to something that's very compact, that is actually at human scale. And we've been able to test this against, I've said here hundreds, it's actually thousands. One project alone looked at over 1,400 different data formats from 1,400 different organizations and brought them together into a single repository using the CRM to drive that process. So we're actually looking at thousands of data formats that we're able to explain sufficiently well to integrate them. We started putting it into the ISO standardization process, so ISO Technical Committee 46, in September 2000, which was a few months after I started on the project. I started on the project in June of 2000, and the last Internet ISO version was done in 2014. And as George mentioned earlier, we're just about to push version 7.1 into the sausage machine that is the ISO process, so that we end up with going through the 5-yearly maintenance program. So every 5 or 6 years, you have to go back to ISO and say, here is a community of use who think the standard is still useful, and here are any refinements that we want to make to it, any corrections that need to be done. So that's part of that ongoing maintenance program in the ISO world. So the CRM-SIG acts as a community of expertise in the use and development of the ISO standard. And so the things that we do in our community edition, so 7.1, will be pushed into the ISO process. And so we should see a new ISO version, ISO 21127 2021, sometime in the next year. It's not a quick process, the ISO process. It has the opportunity for lots of people to make comments, and we react to those comments. And sometimes that means that we find that we've got some refinement to do. More often it means that we've got to write an explanation of why the person doesn't understand what it is that they've said is wrong. Anyway, so that's the background to where we host it. So let's start thinking about the design fundamentals. So the core design fundamentals then are as follows. So let's first of all establish what we mean by an ontology. So the CIDOC CRM is considered to be an ontology. So what that means is it's a way of formalizing our knowledge about the domain that we're interested in. So in our case, cultural heritage documentation. So what we want to do is establish a knowledge of all the possible states that it can occur in the domain. And we do that by clearly defining a set of concepts or classes which define the things which we deal with and the relationships that can exist between those things. So the concepts we call classes and the relationships we call properties. And the idea is that the results can be processed both by machines, our favorite computer, or they can be processed by people. So we want it to be readable by humans. It shouldn't be something that's so arcane that only computers can understand it. We need it to be in the middle ground so that experts, us, can read the data and actually follow what's going on, as well as getting machines to do it for us. So, we want the machines to do the boring bit. We want to do the interesting bit of actually reading this stuff and finding out what's going on, those exciting new insights that we're going to generate. And we don't want to have to do that only through a computer. So let's start thinking about classes then. So classes are categories of items which have common traits. That is, that they share a particular set of things that we can observe about them. We define what the class is in a scope note. So it's a verbal description, a written description of the intention of the class. So the intention is that all of the things that we want it to be. So a description of all of the traits that this class has that allow us to say that something belongs to the class or not. So does somebody have a question? I can hear an open mic. Okay. So no, I'm still talking. Right. So the intention is then the set of all of the traits that a class has, and then individual items that belong to that class, that are members of that class, are called instances. So the language we use is we say this is an instance of this class. So I am an instance of the E21 person class. Now, we assume that this is an open set, that we will never know all possible instances of a class. So person is an ideal example. We don't know all of the people that have ever existed in the past, and we don't know all the people that will exist in the future. In fact, we probably don't know all the people that exist at the moment. So we can't have a complete listing of everybody. So the extension is all possible examples of the class that we can maybe know some of them, but we'll never know all of them. And that leads us to this concept of an open world. We always make the decision when we're understanding a class that we can't possibly know everything about we can't possibly know every member of the class. So we must make an open world assumption that there will be instances of the class that we do not know, that we yet, or indeed may never know about. Okay, so that's the open set idea, the idea of an open world. And that does have some implications for design elements later on. And we made a decision back in the day when we were first doing this, that we were going to call them, we weren't going to call them classes, we were going to call them entities. It's a hangover from the relational days where we started. And so we started naming our classes with the letter E for entity. And then we decided that actually they were classes and not entities. So we couldn't be bothered to change. So classes have the first letter as a capital E and then a number, XX. And consequently, all classes start with the letter E in the core CIDOC CRM. Now, I mentioned there that the definition of a class is actually a text definition. And here is the example of one of the core classes, one of the central building blocks of the standard, a thing called a temporal entity. And you'll see that it has some structure to the way it's described. So at the top, we have this idea of a subclass. So that is a class above us, which this one belongs to. We inherit all the capabilities and qualities of the class above us, and we can pass on our traits to our subclasses. So we are the superclass of, in this case, temporal entities are the superclass of two subclasses, E3 condition state and E4 period. Then we have a scope note, which is a text which allows us to explain to other people what it is that we mean by the concept of E2 temporal entity. So this is a description of what the class is, what it's intended to be. And you can see that below that, there are some examples. And the examples are showing us that they are from subclasses. So the Bronze Age is actually an E4 period. And because period is a subclass of temporal entity, it's an example of a temporal entity. The earthquake in Lisbon is an E5, which is actually a subclass of E4 period, an event. And the Peterhof Palace in St. Petersburg being in ruins between 1944 and 1946 is an example of an E3 condition state. Where possible, when we're giving an example, we'll give a pointer to some documentation that illustrates, which will enable you to find out some more about the example. And sometimes we'll give a description of why it's an example as well along the way. We provide first order logic, which is a formalism for a formal way of describing what it is. So this says that E2 is every E2 is a sub class. So E2 is a subclass of E1, and therefore every example of E2 is an example of E1. And then we have the properties that this class links to, that this class links through to other classes. So in this case, we have P4 has time span, is time span of E52 time span. So we see that we have a statement which tells us how to get somewhere and where we're going to. So we're going to go from a temporal entity to a time span. All of our subclasses inherit the properties that are declared at this superclass level. So all condition states and all periods also have these properties P4, P173 through 176 and 182 through 185. We'll come back to those later on in the workshop. If you haven't read the scope note and all you've read is the class name, then you don't understand what the class is. It's only in the scope note that the definition of what is going on is clearly explained. So never read the class names and go, oh, I know what that is. You probably don't. And this is a particular favorite of archaeologists because they read some of these. I am an archaeologist. That's why I'm bad-mouthing archaeologists. And they read some of them and they go, oh, yeah, I know what that is because we use that term all the time in archaeology and I know what archaeologists mean by it. No, you don't. You don't know what an E4 period is. Typically, archaeologists have a very different idea of what an E4 period is to what an E4 period actually is in the CRM. So you always read the class scope note before you make any decisions about what it is that you're going to do with the class, before you understand what the class is actually about. Right, let's move on. Any questions so far? Questions in the text chat? I'm getting overexcited here. I'm getting too hot, so I'm going to take my jumper off.
Stephen?
Hello?
Stephen, I just wanted to say chat is disabled for me, and I can't see anything in it. I didn't know if that was true for others.
Well, I'm very sorry. Let me see if I can turn it on. Everyone publicly and privately. How's that? Can you see what's in there already?
Yes, now I can. Thank you very much.
Yes, that would make life a lot easier. Thank you for pointing it out. That's very helpful. I thought it had magically turned on for me, therefore it would turned on for everybody, but apparently not. Okay, so that was the class scope note. So let's talk about the other building block that I've mentioned. We've talked about classes, now we're going to talk about properties. So properties are relationships between two classes. And again, they're defined by a scope note, and the scope note has an intention, so that the qualities that this property is encapsulating between the two classes. We always give them a domain and a range. That is, they go from a class to another class. It's an arbitrary choice about which way round, which one's the domain and which one's the range. We have some rules about where we're going to start from, which ones are going to get labeled up first, and I'll talk about those in the next slide. But they're all bidirectional. They all mean something in the opposite direction. Now, some ways of representing this in the implementation world of IT and computers find that a bit difficult, and they want them to be two different classes, one going from domain to range and a different one going from range to domain. That's an implementation issue. I don't care. When we're declaring them, we're making the link so that they can be bidirectional. I can go from the domain to the range, or the range to the domain with equal, well, just equally. Equal ease. Now, another thing that we have, which really upsets some of the computational people, is we have the concept of properties of properties. So this is, we can say that a property has a type that allows us to type the properties. Now, the reason we allow this and we point to it is it allows us to have a far more compact standard, and it allows us to be open world. So you can just add as many new types as you like. Whereas if you lock it and say, right, these are the only types that you can have, then you actually close the world, so that people who have a different set of values can't integrate with you because you don't match. So we allow properties of properties rather than typing the properties directly themselves. So we have this ability to go off to an extra lookup, and I'll show you how that works as we go through later on. But this is, this is familiarizing yourself with the basic building blocks, the basic concepts. Where are we? So how do I name properties? Well, like we knew we were going to call them properties, so we started labeling them with P's. So they start with a letter P, and then they have a number after them. They're all lowercase, whereas the class names have a capital first letter. It's not camel case, something similar to camel case. They're all lowercase, and they have a bracketed part. Nearly all of them have a bracketed part. There are a few where they're symmetrical, where you can read them in either direction, and you only need one text name to describe whether you're going from domain to range or range to domain. So those symmetrical ones, we don't have a bracketed part, but pretty much everything else, everything else will have a bracketed part if they're not symmetric. So when you're reading from the domain to range, you read the non-bracketed part. And when you're reading from range to domain, you read the bracketed part. So if you're going backwards, you use the bit in brackets. If you're going forwards, you use the bit that isn't in brackets. And as I mentioned, we have a priority list for which way we decide is the domain to the range. And we consider the CRM to be what we call event-centric. We think that the driving thing is not the objects, but the events, the things that happen. And consequently, we say that wherever there is a relationship between two classes, where one of them is a temporal entity, a thing happening, an event of some type, then we will always start from that and go to the other. So we never drive from the object to the event. We always drive from the event to the object, to the physical or immaterial thing. So that's how properties are named. And as I said, properties have scope notes, and they have exactly the same type of thing as we saw for classes, but we have this extra information about domains and ranges and a few other little neat bits. So the domain is where we're starting from when we're going to read it, and the range is where we're going to end up. So if we're going to go from the domain, in this case an event, to the range, in this case an actor, then we'll read the section that's not in brackets in the property's name. So if we're going from event to actor, we would say the event had participant actor. But if we were going from the actor to the event, we'd reverse it. So we're going from range to domain. So now we'll read the bit that's in brackets. So if we're going from the actor to the event, we'd say the actor participated in the event. Now you can see immediately that this stuff is designed to be read by humans. It's not just a binary representation of the relationships we have. It's something that's actually intended to show us the way the data actually works, so that you as a human can read it and find out what the heck's going on. It's not locked inside the computer like it would be if we use some binary representation of the relationship. So it's intended to be read. It's a bit stilted. It doesn't read like nice prose, but it definitely reads. And that's the intention of the way we've built it. So again, this property has a super property. So it's a sub property of P12. So P11 had participant is a sub property of P12 occurred in the presence of. So the more general concept is it occurred in the presence of, and then there was participation. And then it's a super property of all sorts of specializations of participation. So activities being carried out by somebody, being given birth by a mother, the dissolution of groups, and so on. So these are activities that, or things that we're going to do. We're going to have relationships between events or sub-properties of events and subclasses of events, sorry, and other classes. Now, we have a quantification. Now, quantification tells us, in the real world, what would we expect the relationship to be between an event and an actor? And in this case, we'd expect an event to have many actors and an actor to be involved in many events. And we give two different representations of that. The traditional sort of relational many to many, and also this syntax of 0 to n, 0 to n. They're explained in the top of the document, so you can use either one of them. They're just two equivalent ways of describing how many of each can be on each end of the link. Then there's the scope note. And again, if you haven't read the scope note, you don't know what the property means. And then there are some examples. So here we've got Napoleon, who's an instance of E21 person, participated in the Battle of Waterloo, which is an E7 activity. And Maria, E21, another person, participated in the photographing of Maria, another activity. And then again, we have the first order logic. So if you want to get into first order logic, every property and every class has a full description in first order logic of what it means, so that you can apply that if that's useful for you in your context. If you don't want to use first order logic, that's absolutely fine. We're just trying to be thorough. So that gets us to the first exercise I've set you. So if you go to the exercise worksheet that I pointed you at in the Dropbox link that says workshop exercises, you'll find a little worksheet where you can look at these 7 different names for things and tell me whether you think they're a CRM class, whether you think they're a CRM property or whether you think they're nothing to do with the CRM. It's just some random stuff that I put on the slide to check that you were paying attention. So just go through each of those oh, George, you don't have the links. Maybe I should repeat them then. Yeah, absolutely. They've obviously not got through. So I'm just copying and pasting them below. But I need to turn that off. Everyone in meeting. Right, okay. So that's the CRM as a whole. Here's the exercise sheet. Here's the presentation notes for what I'm showing you. And in a later exercise, you're going to need a property hierarchy, which is here, and a class hierarchy, which is here. So these are just copied out of the 701 standard that I've also given you the link for, just to make life a little bit easier, so that we're on just a couple of pages instead of having to scroll through the whole document to get that information. So I'm going to give you just a couple of minutes to have a go at that now that you've got the links. So I'm going to give you 5 minutes from now, and then I will reveal the answers, and you can pat yourself on the back or go, I really didn't get that, as we go through the answers. And if you have questions about what's going on, or well, anything really, stick them in the text chat now that I've got that working for everybody. And some of the people who are supposed to know about the CRM, I expect perfect answers from you. The weasel is watching, Mark. Ah, you've fallen into the trap, Robert. Excellent. We can't do thumbs up in Zoom, can we? No. Okay, I think we're pretty close to 5 minutes now. So let's start with, anybody want to guess what linguistic object is it? Is it a class, a property, or not part of the CRM? Yeah, there's a lot of people putting C in. So let's see if, yeah, there you go. It's C. Yeah, it's a class. It has that classic structure of a capital E, a number, and then multiple words with each with capital letters, starting with a capital letter. So that's the proper way of naming a CRM class. Right, what about the next one? C45 address. Yeah, lots of people getting that right. So yeah, it's not part of our scheme, our addressing scheme, because it starts with the letter C. It would make sense for us to have started with the letter C, but as I said, historically we started with E's and we've stuck with them. 20 years of bad habits. And now, what about J67 measurement event brackets measuring close brackets? What do we think of that? Yeah, that's right. That's not part of anything. It breaks every rule. It's fantastic. I put my heart and soul into that. Right. What about P1 is identified by identifies? Okay. People think that's a P. Oh yeah, you're right. Well done. What about P1 is identified by identifies? What do you think that is? Yeah, that's right. It breaks the rules, doesn't it? It's got capital letters. So well done for spotting that. E42 identifier. Yeah, that's a class. Follows the classic rules. And then P81 ongoing throughout. Yeah. It's one of the unusual ones in that it doesn't have a bracketed piece because it's symmetric. So that was just to illustrate that there are symmetric properties out there, and that's one of them. Well done, everybody. So I've mentioned as we've been speaking about the classes and the properties that they have super and sub properties. And this is because they're organized into what we call a hierarchy or hierarchies. So the classes are arranged in a hierarchy with super classes having subclasses, and you inherit all the properties from all of the super classes above you. So it's not just the one immediately above you, but the superclass that's above that as well also passes all of their properties down to you. So you can use any of the properties that are declared explicitly for a particular class and all of the classes that this class is a subclass of or a subclass of, and so on. Properties are also arranged in a hierarchy. And that's to enable us to make queries where we can query at a general level and find out all these specializations. So we looked at some of the specializations of participation earlier on. So being a mother or exchanging the ownership of an object. If we wanted to just look at general participation, we could query at the top level of the hierarchy, but if we wanted to be more specialized, we could query further down the hierarchy and just look at particular sub-properties. So here is the properties hierarchy around occurred in the presence of. So this is general participation. I'm going to look at I'm going to come back to this again in a little while, so I'm not going to drive into it in any detail now, but you can see that P12 occurred in the presence of has what is it? 1, 2, 3, 4, 5, 6, 7 direct sub-properties, and then they in turn have their own sub-properties down to up to 4 levels. So I could query with P12 and get everything below, or I could drill down a bit and perhaps use P14, and then I'd only get P14, P29, P22, 23, and 28. So the hierarchy allows me to have a very flexible approach to querying. And we also have a hierarchy for the classes. So this is one of the attempted color schemes for this. Perhaps not finalized, but it's an attempt at driving a color scheme. I think it looks a bit pink personally, but hey. And here we can differentiate between the things which happen and primitive values, which are at the top, and the persistent items, the things that we tend to want to keep track of. So people, immaterial ideas, and physical things. And we're going to drill into different bits of this in more detail as we go through the rest of the material. So I'm not going to dwell on it really, just to let you see that there is a hierarchy which starts at this E1 CRM entity and drives down into everything. I've got a typo there. That arrow should be going further up. Hey ho. Okay, so it's about time you got to explore something about these hierarchies and look at the fact that there are multiple levels within them. So what I want you to do is use the documents I sent of the class hierarchies and the property hierarchies to find out what's the superclass of the class on the left and what's the superclass. So the superclass of the class that is the superclass of the first one being transfer of custody. So what's above transfer of custody and what's above that? So go up 2 levels. So I'll give you a couple of minutes to get stuck into that. Well, Antoine, nice question. In theory, yes, it could be. In fact, I don't think there are any of the extensions which are using C. But yes, in theory, it could have been an extension, but I had deliberately pitched it as being part of the core. But yes, so it is possible, but it isn't. Okay, I think that gets us to the point where perhaps we can start to go through the answers for this exercise 2. So what do people think is the superclass of E10 transfer of custody? You got overexcited there. The superclass is E7 activity. And the superclass, yeah, E5. Good, event. So superclass is E7, the superclass of E7 is E5. Right, E57 material. What's the superclass of E57 material? Yep, E55 type, that's correct. And what's the superclass of E55 type? Yeah, that's right, E28 conceptual object, well done. People find that a little confusing because material, well, I can smash windows with material, but not the concept of the material. So if I'm talking about gold as a material, I can't smash a window with it because it's just the idea of gold, not a particular piece of gold, which would indeed be a physical object. Okay, so that was looking at classes. So now move on to properties. What was the super property of P22 transferred title to? Yeah, P14 carried out by or performed, the reverse. And the super property. Oh, somebody's gone off in the wrong direction. That's a sub-property, Ines. No, P111 is not right. So the actual answer is P11 had participant. Right, what was the super property of P135? Created type was created by. Yeah, everybody's nailed that. It was P94 has created. And what's this? Oh, okay. Well done. Now you know what I asked. You'll be fine. And then what was the super property of P135? Indeed, P92 brought into existence. Because obviously, if you created a type, so it went to the effort of creating an entry in a thesaurus, for instance, it is actually bringing that into existence. Okay, well done, everybody. That's exercise 2 out of the way. So that's half the exercise is done. You'll be glad to know. Then you can relax and just listen to my soporific voice and go back to sleep. Right. So here's a concept which tends to freak out programmers, because multiple inheritance is something that they don't really like if you're writing object-oriented code, but it's very, very useful in a database. So in single inheritance, if we have a museum artifact, we can have different types of museum artifacts. So we've got canisters, which are a subclass of, that's what this hollow arrow is indicating. So canisters are a subclass of museum artifacts, and they have extra information about containers and lids. So they have an extra set of properties. And we also have ecclesiastical items which belong to a church. And if we only have single inheritance, if we have a holy bread basket, it belongs to a church, but it also has a container and lid. And this makes life very difficult when we come to querying, because I have to know all of the places which could have a container and lid if I want to write a query to find all of the objects which have containers and lids. So that makes life quite difficult, because I've got to know everything in quite a lot of detail. Whereas if I use multiple inheritance, here I can say that a museum artifact is either a canister or an ecclesiastical item, and a holy bread basket is both a canister and an ecclesiastical item. So it gets the ability to have belonging to a church, the property belongs to a church, and the properties about containers and lids. So now a holy bread basket, instead of having a separate link to containers and lids, inherits the link from canisters. So it inherits the properties from canisters, but it also inherits the properties from ecclesiastical item of belonging to a particular church. So this idea of multiple inheritance is something key to the way we've built the standard, because it greatly simplifies querying the resulting model. So with that in mind, I'm going to set you the task of finding the superclasses for a couple of, for a class and a property. So we can do this with both classes and properties, this multiple inheritance lark. So I've set you the job of finding the 2 superclasses for E21 person and the 2 super properties for P108 was produced by. So I'll give you a couple of minutes to have a look at that. Right, I think it's time for some answers. So who can give me the two superclasses of E21 person? Okay, yeah. People are getting the hang of this. Yeah, so E21 person, E20 biological object, and E39 actor are the two superclasses for it. And what were the two superclasses for P108? Yes, P31 has modified and P92 brought into existence. So very good, everybody. I think you've got the hang of this multiple inheritance. Often people find that a bit difficult. So we're going to step it up now. Now you've mastered the basic pieces. Now we're going to introduce something which is generally considered to be a bit more complicated. It's not terribly complicated, to be honest, but it often gives people a few more problems. So this next thing is a technique that we use, which is called multiple instantiation. Now, you've probably all played animal, vegetable, or mineral as a child, where you get 20 questions, and from it you have to determine what an object is. So you have to you get given the information, it's animal, vegetable, or mineral, and you then have to work out, just using 20 questions, where the answer can only be yes or no, to get resolve it down to a particular object type. So my favorite one was, I stung my daughter when we first started playing this with the vegetable, which is a cardboard box. Of course, a cardboard box is made out of paper, and paper is made out of trees. So cardboard boxes are in fact a vegetable. And I won quite soundly on that one. So whenever we play the game now, even though my daughter's now a teenager and she doesn't really deign to play games with her father very often, that's always one that comes out as a joke. So if we looked at something which is a bit more complicated, like this wooden handled iron knife with bone inlay, it gets a bit difficult to decide which class it belongs to. It's animal, well, it's got a bone inlay. It's vegetable, it's got wooden handle, and it's mineral, it's an iron knife. So consequently, it is simultaneously animal, vegetable, and mineral. So we would have to either produce a new special type of, a new special class, which was objects which were animal, vegetable, and mineral, which means we'd also need a class for vegetable and mineral, and a class for animal and mineral, and a class for vegetable and animal, as well as classes for animal, vegetable, and mineral. So it starts getting awfully complicated awfully quickly. So what we decided to do was just say, well, if you need more than one class to describe something, take more than one class. Don't create a new class which is the combination of them, because that will be monumentally complicated and inefficient. Just instantiate the object as more than one class, and that way we'll be able to have a much simpler structure which doesn't start to fracture when we meet all sorts of more complex objects or more complex events that we hadn't initially seen, but we knew we had the building blocks for. So if we look at the example I've got at the bottom of the screen, which is a museum gaining an object, so an object entering the museum that the museum is going to take legal ownership of, going to look after it, and it's physically moving to the museum and it's going to live in the museum. Right. So we have an E8 acquisition, so that's us taking legal ownership of it. An E9 move, the object is actually coming to the museum, and an E10 transfer of custody. We're going to look after it. So that's a very typical example, but we might have a museum gaining an object where the object isn't going to move to the museum. So we'd have an acquisition, but we might still be looking after it. So it's a transfer of custody, but it's not actually going to move to the museum. So it's going to stay perhaps in the shunting yard of the railway company that originally owned the engine that was now part of the museum's collection. Right, so that's the idea, is that we're going to use multiple instances of classes to describe things which are more complex, so that we don't have to have every possible combination as a separate class in the standard. So if we move on from there, let's have a think about multiple instantiation for a loan or a field collection. Sorry, Robert, except that each of these aspects can have different properties. The acquisition likely happens before the move, and the transfer of legal custody is carried out by lawyers rather than couriers. But keep going. Okay, thanks, Robert. It depends on the granularity that you wish to document things at. If I just want to fill in a record sheet for the fact that this object was brought to the museum and we took control of it, and I don't want to go into the details of 11:47 it arrived and at 11:48 they signed it over, then the level of multiple instantiation is sufficient. If, however, I do want to document things to the split second of when things happened, then I can just have a set of instances of each of the things with their own time span referring to the same object. So it doesn't make any difference whether I have multiple instantiation or not. Multiple instantiation allows me to build things where I don't want to go into the fine technical detail that there might be in the sequence of events. That still doesn't change. If we're just going to document a loan in one thing, and we're not going to talk about every split second in it, what classes might I need for doing a loan? And what might be the classes I need for a field collection? Right then. Seems likely that some people will have some answers by now. So which classes do we think we need for a loan? Transfer, the acquisition, well, if it's a loan, we're not going to be acquiring it. With transfer of custody, yes. I'm not sure why it would be an authority document. An authority document is a document which lists terms in your thesaurus. Identifier, not so much. E55 type, not likely to see. Transfer of custody and move. Yes, they're likely to be, but they're not. E53 place is a place rather than an event. E14. No, I don't think so. No, it's not going to be a condition assessment. We might do a condition assessment. Yes, I suppose so. So yes, place is in the sense of a location, but that's a place. So you would be putting something in a place, not the act of doing isn't itself a place. Yes, well, period, Camilla, that's very insightful, because in fact, an acquisition, transfer of custody, and a move are all individually places. E86 leaving. Now, you haven't read the scope note, which is hardly surprising, given that I haven't given you any time. Leaving is when you leave an organization. So not leaving something behind, which would be a loan. Right, so what we have is a move. The object has moved to the place which is the museum, and it's a transfer of custody, but it's not an acquisition because we're not transferring ownership. It's a loan. We have to give it back. So the museum doesn't end up owning it. It just has it for a period of time. And if you're following Spectrum, an agreed period of time. Although quite a lot of museum collections have objects which were loaned by somebody with no terms. There's no length to the loan, and consequently they don't know when they need to give it back, and the person doesn't know when they're supposed to get it back, and it can all lead to bad things. Right, now if we look at field collection, it gets a little bit more complicated, in fact. So it could be an acquisition. It depends on the nature of the way it's collected in the field. Some archaeological objects, for instance, if you collect them in the field and bring them back to the museum, they become the property of the museum. Other things are the property of the person that found them, and other things are the property of the person whose land they were discovered on. So it would depend on exactly which one of those circumstances came to pass. And that's why having well, we can bolt an acquisition in if we need it, is far more utilitarian than having a special case for each possible legal circumstance. It might involve a move. The object might come to the museum when we've collected it, or it might not. We might discard it again, or it might be too big to move to the museum, or it might be an elephant, and we're not allowed to have elephants in our museum because they get footprints in the butter. Or it might not be a transfer of custody. We might not take control of it as a museum. So it might be left where it is. So there's no move, there's no transfer of custody, but we might take legal ownership of it, even though it's still in the field where we found it. So that's why we have this ability to bolt things together rather than make a definitive set of possibilities. And that's where multiple instantiation gives us a huge amount of power. Instead of having to prepare every possible set of legal connotations for every different legal regime in the world, we can just have these fairly basic principles, which we can then bolt together in combinations, which give us the subtle variants that are present in each legal system and for each type of transaction which brings an object into our world of documentation, whether that's physically arriving in the museum or not, and us owning it or not. So that's the idea behind multiple instantiation. It's very powerful, but it does take a little getting used to. And it can mean that you actually want to start documenting things in slightly more detail than you do already, so that you can differentiate between these different aspects of a process that brings objects into the purview of the museum, for instance, or other things. So that was exercise 4, the last of those. So now what we're going to start talking about is what you can do with it. What's the functionality that we've built into the descriptive content of this ontology? What states of affairs in the world can it actually describe? So that's what we're going to look at now. So different types of relationships. So one of the fundamental things that we like to do is give names to things. So those names could be strings of numbers and letters to identify it, or they could be the names of people or places or things. They could be colloquial names or proper names. And all of those things we want to be able to record that the real world object has been given a name. And we want to distinguish between the identity of something and its name or names. So you can call me many things. Some of them are rude and some of them are just variants of my name. And some of those names can also be applied to other objects. So Stead, for instance, short for Stephen Stead, also applies to my grandmother, Susan Stead. So all of those things, we want to differentiate between the thing and its names, and those names can be used for many objects. So that's one of the sets of relationships that we provide for, the difference between identity and naming. We want to be able to observe and classify things. So the observation, so being able to see that something is somewhere at a particular point in time, and for us to classify it, for us to put a typology on it, are key aspects of the things that we as humans do, particularly as scientists. We quite frequently want to take things apart into smaller component parts. So generically, this is known as part decomposition. So we can take objects apart. So we can look at a table and consider its legs and the top. We can take a pen apart and consider its nib and its spring and its barrel and the clip. Or we could take a car apart into its engine and wheels and transmission and so on. We can take periods apart. So we can talk about the Bronze Age, or the early Bronze Age, the middle Bronze Age, and the late Bronze Age. Or we could have the early late Bronze Age and the late early Bronze Age, and the late early middle Bronze Age, and the middle early Bronze Age, and the late middle Bronze Age. All of which are different periods of time. So we can, and we understand the relationships between them. And we can take places apart. So we can think of the room that you're in as being a place, which is in a building, which is in a street, which is in a town or a city, which is in a country, which is in a continent. So we can decompose places into smaller places or aggregate them into larger places. And we can also do this thing, which is the participation of persistent items in temporal entities. That sounds awfully complicated, doesn't it? Right, so what's a persistent item? A persistent item is something that if you look away from it and you look back to it, you know it's the same thing. So it has an identity that exists beyond the length of time that you're observing it for. So if I look at this light and then I take it away so you can't see it again, and I bring it back, do you know it's the same light? Well, if you look at the bottom and you can see, well, you probably can't see, but there is a serial number on it, you can identify that that's the same light. I didn't swap it when I moved it out of your sight. So that makes it a persistent item, something that we can re-identify. So participation is taking part in temporal entities are things that happen in time. So we're talking about things that we can continuously identify taking part in things happening. And that is basically history. So it gives us this notion of history. If we have a series of events that objects have taken part in, people are objects in this way, they're persistent items. If I do that and then come back, you can still see it's me, right? So I'm a persistent item, very persistent, some people say. That way, you can take part in a series of events and thus take part in history, form part of history. So that's the idea behind this concept of participation of persistent items in temporal entities. That gives us history. Another set of relationships that we have is the idea of location. So we locate periods in space-time. So periods are social cultural phenomenon bounded in space and time. So a period exists in a particular place for a particular period of time. So you can't talk about the Roman period. You have to say the Roman period in the UK or in Italy, and they're different. They have different temporal extents in different space. And we can also talk about the location of physical objects in space. So where something is. So where is my light? Where is the weasel? We want to talk about influence. So we want to talk about the influence of objects on activities. So I made this wedding dress for my wedding, or I made this ring for my wedding vows. And we want the other way around. We want activities having impact on objects. So the smashing of a plate, the creating of the Eiffel Tower. So those are influences, and we treat those very loosely. So we don't tend to think about causality, very strong causality, because that's it's a very heavy statement to make. So we're quite loose about that. And we also want information objects, so the content of books or databases, to refer to real world things. So we want any information object to be able to refer to anything that we're interested in recording information about. So it refers to the content of our database referring to the items in our collection, as well as books referring to objects, books referring to our museum, biographies referring to people, and so on. So any information object that refers to something else, we want to be able to represent that, because that's useful for us in our study of the documentation that we have within our organization. We also need to be able to express relationships with time, and we have a fairly simple model for time. We categorically deny the possibility that an event happens at a point in time. Events always have duration, which we can measure, and so we can have a dimension of the time. We use a relationship between the event and the dimension of P191, which is in the standard. And we also say that events happen at some time within. So we have these before and after. So we call these the outer bounds. So it definitely happened after the before and before the after. So it happened somewhere in this bracket. We may also know that it was definitely happening at some period of time within that, which is the P81 ongoing throughout. And this we refer to as the inner bounds. So no, it was definitely happening in this chunk of time. And we know that it occurred entirely in this much wider chunk of time. So that's the way we model the relationship with time. We also have the ability to talk about the relationship of events with each other. So we can have temporal entities which have relationships with other temporal entities, saying that they were before or after or started alongside. And we have 8 special operators which allow us to describe all of the possible relationships between temporal events which have what we call fuzzy edges. We don't know exactly when they started or stopped. We have some boundary. Well, they definitely weren't happening here, but they were probably happening here, and they definitely were happening here. There's a fuzzy bit here. So we have some special relationships which allow us to talk about how things started before, after, during, or with other events. So as I say, there are 8 of those. We used to support what are called the Allen operators, which are far more simplistic relationships between events, which assume that things have very hard edges. Now, they're quite useful, the Allen operators, but we decided to retire them from the core CRM and put them in the extension CRM Archeo. So they're still available, but they're now in an extension for those special circumstances where they are a realistic representation. Well, they're as good a representation as we have in the documentation. Archaeology is one of those cases. So that's why they're in CRM Archeo. So let's try and put this together with an example of a real world example, and then I'll show you a documentation for that using the CRM. So we're going to look at this, this classic example of this chap Winckelmann, who saw a copy of a Roman statue. So in antiquity, a Roman had created a copy of a Hellenistic, a Greek statue, and Winckelmann, this Austrian guy, German guy, saw this copy, and then went on to write about the history of art in antiquity. So we know that there was a copy of the original statue, which no longer exists. The original statue, the original statue no longer exists, but the copy carried on and was seen by Winckelmann sometime between his birth and when he wrote this book, The History of the Art in Antiquity. And then he wrote that before he died. And this happened in a number of places. So we have a timeline for it happening. So his birth was in 1717 and he died in 1768. And the original was made in Greece. The copy was made somewhere, we don't know where, but it was held in the Vatican. So it was kept in the Vatican, and that's where Winckelmann saw it. And he wrote his work in Dresden, and he died in Trieste, and he was born in Stendal. So these are the spaces along the bottom and the timeline at the side. So let's see how we can represent that with classes in the CRM. So here we are looking at that. So here is Winckelmann, who was born in 1717, and his mother was Anne Maria Meyer, and he was born in Stendal. And then on the left-hand side, we have the Lacoon group, which is a copy commissioned by some Roman, and they could see the original Lacoon group, which was a Hellenistic statue. And then Winckelmann saw Lacoon in this big central E5 event, and in 1755 in Rome, in the Vatican, and he then subsequently wrote this book, The History of Art in Antiquity, in 1764. So this was an information object, the E73 at the top left, and the creation event, which was him creating it. And it refers to this statue, the copy. And then Winckelmann died in 1768 in Trieste. So you see all of those different elements that we saw in the squiggly diagram are now represented with much firmer object, which we can now start to do reasoning with. So we know that he saw Laocoon in 1755, and that mustn't necessarily have been after his birth. So we can start to relate these things together, even if we don't have actual documentation of when these things happened. So this kind of representation gives us the ability to integrate data from different sources. So we may have some information about the Laocoon from one museum. We may have biographical information about Winkelmann from another institution, and we might have information about the history of the art in antiquity, the information object, the book, from a library catalogue. So we might be drawing information from many sources together to start to tell this story about Winkelmann seeing a statue and writing a book based on what he saw. Okay, so where are we? I think we're going to start looking at some of the content. So are there any questions about any of these building blocks that I've been talking about so far before we launch into having a look at some of the content of the standard itself in more detail? I'll assume if nothing appears on the text chat that nobody has any questions. So let's move on to the CRM itself. So having a look at some of the content. So this is, this is a very old diagram, which still does a remarkably good job of summing up the CRM. So I think I first saw this diagram nearly 20 years ago. And it's still an incredibly powerful way of describing what's going on. So at the core of the model, as I said, it's what we call event-centric. At the core of the model, there are these E2 temporal entities. These are things happening in time, the so-called perdurance. So things which occur in time. So activities, events, happenings, history carrying on. And these are the things that give us links to time. So E52 time spans are our way of looking at time. And it's the only way we can get to time. So we can't attach physical things and conceptual objects to time directly. We have to go through a temporal entity because there is nothing 2018 about this light. It isn't 2018. There was the making of this light in 2018 and my buying this light in 2018. But there's nothing about the light itself that's 2018. It has no link to time directly. There are only things that have happened to it which give it its place in time. So we've got temporal entities and time spans. We have places. So places are mathematical boxes within which there is stuff at a particular point in time. So I find the easiest way of describing a place to somebody who's not used to the concept of a mathematical box is you can't take a picture of a place. A place is just a mathematical construct in space. You can only take photographs of the stuff that's in a place at a particular point in time. And yeah, you can do that. So temporal entities happen at places, and physical things and immaterial things can be located at a place. And then we have actors. So these are individuals or groups of individuals which do stuff that we're interested in. So they have some responsibility for their actions. That's a key element of our understanding of what an actor is. An actor acts in that they are responsible for what they do. So monkeys aren't actors, despite some of our politicians being like that. So then we have physical things and conceptual objects. So these are the things that we're interested in. So physical things are things that you can smash a window with, and conceptual objects are the products of the human mind. Now, there's a fundamental difference between physical things and conceptual objects in that physical things can be destroyed. And by destroyed, I don't mean taken out of existence and converted into energy. I mean they can be broken up into components which we are no longer interested in documenting. So they can be taken out of the world of documentation. So physical things can be destroyed, but conceptual objects can never be destroyed. They can be forgotten. We can lose the last carrier of them, but the conceptual object itself cannot be destroyed. So if we lose the last carrier, where that carrier can be the human mind, a la Bradbury's Fahrenheit 451, we can lose all carriers of it, but we still know that it existed. So we can still write documentation about it. So Sappho's poetry, for instance. But we can't actually destroy, you can't destroy a book. And just to put you in the picture, if everybody wanted to actually get rid of the CIDOC CRM, they'd have to, come and delete my laptop and all the servers that we've got it on, and all the paper copies that have ever been printed, and all the people who've got it downloaded into their laptop. We'd have to destroy all of their laptops as well, and then we'd have to go around and kill every one of you and me. Right? Because you're now a carrier of the CIDOC CRM. You know enough about the CIDOC CRM that you can be considered a carrier. And so we'd have to kill you as well. I'm just saying that so that you don't think that you can get rid of it ever. You're in now. So those are physical and immaterial things. Now, there are two things that I've already mentioned that we do a lot of. The first of those is we name things. So this idea of adding appellations to everything that we document. So giving names to things is one of those key human characteristics that we do. And the other thing we do is we classify things. We put things in immaterial boxes. We say that they belong to a particular class. And that's what E55 types are for. So this allows us to have many different naming conventions applied to the same objects. So names can be shared. And names themselves are conceptual objects. So we can talk about the history of the name and how it came into being and how it was used in exactly the same way as we can apply it to things. And types can be applied to everything that we have. So we can have types of names, we can have types of conceptual objects, we can have types of lamps. Types, again, are themselves conceptual objects. So we can document how they were created, how they've been used through time. What this means, one of the nice things about the CRM is that because the way we document is itself a conceptual object, we can carry our thesauri and our naming conventions and our processes for doing things in the same container as we're carrying the fruits of those labors. So as we document our collection, we can put into the same container the documentation of how we've documented and the documentation of our thesaurus, our word lists that we've used to document, so that they can all be carried around in a single logical container. And this greatly improves the longevity of the documentation that we're creating. Some years ago, there was an excavation in Southampton in the UK where a lot of pottery was analysed. So they very carefully measured a whole stack of pottery, and they did some complex for the time computing on it, which needed the Southampton City Council's mainframe to do the computing on. So this was long before personal computers and laptops and so forth. At the end of the process, they asked the Southampton City Council if they would keep the data for them. And the council said, yeah, okay, how long do you want to keep it for? And they said, well, forever, basically. And they said, yeah, okay, we can do that. It's not very big. We'll look after it for you. So for the next 20 odd years, every time the council updated their mainframe, they would update the data and make sure that it moved from one version of operating system to the next. And every year they carefully managed the backup tapes that it was on so that it was still readable. And after 20, 25 years, somebody said, oh, you know what, it would be really useful to have a look at that pottery data because we've dug the next slot over in the city and we've got the pottery from the next plot in the city. Let's compare these two and see whether they're from the same type of thing. So they went back to the council and they said, could we have that pottery data? And they said, yes, certainly, here it is. And they got it out and they went, oh, it's got lots of codes in it. Can you tell us what the codes mean? And the council said, no, that wasn't our job. You're supposed to remember what it meant. We just looked after the data. Now that's exactly what can happen with archives of data from museums. If you don't know what the terminology means or the practice that was used to document it, when you get the data out in 150, 200, 300 years, you have no idea what it means. But if you've embedded all of your working practice and all of your documentation standards and all of your thesauri and word lists and meanings into the same container, when you open the container, you can read all of that information. So you have the context so that the documentation lives beyond the organization that originally created it. This is one of the things that we recommend for museums to do as part of their Blue Shield preparation. So, you know, before your museum gets washed away or blown up or burnt to the ground or whatever, you have a way of protecting not just the documentation, but also the meaning of the documentation. So, enough pessimism. Let's move on to something else. So here are the participation properties that we looked at some time ago. Is there anything there that I particularly want to pick out? Not really. We've had a look at that. So let's move on to the next thing. I need to click over here. So this is the temporal entities. So we're drilling down through periods into events and activities. And we've had a look at some of these different activities. Ones that I particularly like to look at is production, which is the beginning of existence of something, and also a modification. And then the difference between modification and transformation. In modification, you take something and you update the material that makes the thing up, but you don't change its identity. In transformation, you keep the material, but you change its identity. So if I convert a windmill into a house, that's a transformation. Right? It's the same material, but I've changed its identity. It's no longer a windmill, it's now a house. It has a different function, it has a different identity. Whereas if I take my laptop and I replace the keyboard, I've changed the matter, but I haven't changed the identity. It's still Stephen's laptop. So those are one particular interesting elements. So these are things. So here we can see the difference between material and immaterial. So the things on top are things we can smash windows with. The things underneath are the products of the human mind. So we can represent symbolic and propositional objects. So the difference between the meaning of something and the way it's presented on the page. We have linguistic objects and visual items, and we have documents. So documents are things, immaterial things, which make statements about the real world. So they're making some proposition about the real world that's intended to be truthful. An E32 authority document is that special case of document which talks about thesauri. So you use an E32 authority document to explain your word list, your thesauri, your whatever you're using to control your vocabularies. Your controlled vocabularies are documented in authority documents. So they're very powerful if you want to try and make your documentation system live beyond its current iteration. We have actors. So I've mentioned them before, that they can be people or groups of people, and that obviously people are simultaneously biological objects as well as being actors. So that's a multiple inheritance example. that we've already looked at. These are time spans. So temporal entities have time spans which are ongoing throughout some time primitive, or maybe at some time within. So ongoing throughout is the inner bounds, at some time within is the outer bounds. We can, in some circumstances, we can say the time span that's defined by this particular time primitive. So the time span that's defined by, say, January 2021. That's a time span that's defined from a time primitive. So we can talk about that. We mentioned that things can have duration, the P191, that's the bottom right. And then this loop around where temporal entities are related to themselves, that represents all of these 8 special relationships where things are related to each other, starting and stopping. So I mentioned this as being the successor to Allen operators. So despite, before, or at the end of. And there are very good graphical representations of the relationships between the domain and range of these properties in the standard, which make it much easier to understand why we've rewritten these to deal with time which has fuzzy ends rather than really hard ends, which is what Allen dealt with. So if you're interested in Allen operators, they're off in CRM Archeo, but these are the real deal. And this is a really powerful innovation within the CIDOC CRM. It gives us an enormous expressive power for relative time calculations. Now, here are some building blocks which we've mentioned as we went through that I just want to quickly talk about in the last 10 minutes or so. So here we have the P2 has type, which is a very common, and you see that it comes off E1 CRM entity. So that allows us to type everything because everything is a CRM, an E1 CRM entity. So everything gains this relationship, this property, P2 has type. And we also have the construct of properties on the left, where we have P3 has note going to a string being a primitive value. And I can say that the has note has type. So I can say that this string is the catalog description. This string is the label for the object, case label. This string is the report, the conservation report for this object. And I also have the 0.1, a property of a property between E7 activity and E39 actor. So here we can say that this activity was carried out by an actor in a particular role. So in this case, we can say that this activity, taking a photograph, was carried out by an actor, Fred, in the role of photographer. And this allows us to be very much more refined about the way we describe people. So many databases in the past have said that Fred was a photographer, but he wasn't born a photographer, and he probably didn't die as a photographer. He just took some photographs. And so the activity of taking the photograph, in that activity he was a photographer, but in other activities he wasn't. And it was very difficult to record things like the people who started off as journeymen and eventually ended up as the architects of a cathedral. Because if you said they were an architect, the person was the architect, at the beginning of their career, they weren't. They were just a journeyman stonemason. And they worked their way up to becoming the architect of the cathedral. And you want to look at different periods of time, different phases in the production of the cathedral, where they had different roles, where they were as a journeyman and then stonemason, and then worked their way up the hierarchy to eventually become the architect. So by using this .1 in the role of, you can much more clearly define the amount of influence that a person had on a particular activity. So we can talk about exactly what they were doing. So that's a .1, which is a useful thing to talk about. The next is another thing that's a frequent part of the standard, and this is the concept of a shortcut. So here we have a measurement where we're measuring a thing and we're observing a dimension on that thing. So maybe the weight of my lamp, for instance, or its height, or its width, or its circumference, or its radius. Right? Now, I may have an event where I actually measured that dimension, and I sat there with a ruler or some other measuring instrument, and I made a measurement of that dimension and determined how many centimeters it was in length or height. Or I may just have recorded in my database that it's, 15 centimeters high. If I haven't got an event where I say who measured it and how they measured it and what they measured it with, then maybe I just want to say it's 15 centimeters high. And that's what this shortcut gives me. It gives me the ability to document what's in the database, even if I don't know how it was determined. It may be that I read the catalog and said, right, well, those are 15 centimeters high, it's 15 centimeters high. But if I've actually gone and measured it, I can use a measurement activity, and I can say, well, I used this measuring at this time, and it was this person who did it, and it was verified by this person and checked, and I can put together the whole process of doing that measurement and document that, if that's interesting, if I have that information. So all of that stuff is stuff that we can put in by using either the long cut through E16 measurement, or we can just use the shortcut, because I don't have any of that information, so I don't want to include it in my system, because I didn't include it in my system in the first place. So why should I include it just because I'm using the CRM? We also have an instance here at the bottom, and you can look at the rest of it. There's some documentation underneath it, where we can see the difference between recording practice, making changes to the way we actually record in the CRM. So at the bottom, I have P52 has current owner, which is a very strong statement, which says that I maintain the information in the system. So every time the ownership of a physical thing changes, I update my documentation. I have a much weaker statement, which is P51 has former or current owner, saying that at some point in the past, this person owned it, but I don't know whether it's still true. So it's not about the statement that this E39 actor owned this E18 physical thing. It's about how well my documentation system represents the truth in the world now. Am I maintaining it or not? So P51 is the more general purpose, slightly weaker statement, whereas P52 is the much stronger statement. So when you're trying to understand the system, you need to look at the details of not just what the statements are in your documentation system, but also the working practice that goes with them. So we're getting towards the end of things. This is some documentation about how place works. So this idea of a mathematical box. And this is how moves work. And the bottom one here, P54 has current permanent location, which is where something may never have been, marks this as coming from the museum world initially, because this is where you say, this is how you do tracking of objects, so that you can check that your documentation says where it is now. So you have a place on the shelf where the object should live, and this is where you document that. And then you go to that place on the shelf and say, it's not here, where is it? Let me see if I can work it out. So I've always liked the idea that you go into your store and you go to a place on the shelf and it says, here is where this object should be. And that object is a 60-ton steam engine, which really wouldn't fit on the shelf, but that's where it should be. So I should be able to follow in my documentation where it actually physically is. And this is the mark of this being a museum standard. So I've always really liked that. And then this is just the idea of modification and production, the idea that we can use materials which don't actually end up as being part of the object. So in conclusion then, CRM is compact, functional, it's an ISO standard. You can use it as an intellectual guide for understanding your documentation. You can use it for a language for analyzing the way you do your documentation. And you can use it as a transport format, both between institutions now, but also to the future by putting your documentation practice into the same container. So we've looked at where it came from, properties, classes, and design principles. We've looked at the idea of it being an event-centric model, and we've looked at some different use cases for it. Well, not a little bit of that. The current version is 7.0. 7.1 will be out in January. And thank you very much.
Thank you.
Thanks. May we have time for some questions?
I think we've got a couple of minutes. Yes, I'm very happy to try.
Yes, just 2 minutes because I need the channel for the next meeting. It's sorry, but we have some minutes. Yes.
Okay.
You can ask your question.
Thanks. Mine would be first. Thank you, Stefan, for this lecture. It was crystal clear and gave me basis that confirmation of some of the basics I did acquired. My question is a little bit broader. You said that the documentation process should be in the same container. When we use like RDF syntax to encode the data, there is this recommendation to use like void or Dublin core to define this the RDF and the properties of the data set. If this data set does use the CIDOC CRM, are there two ontologies that differs? Two different files, or is there a link from the side of from the
you should have inside the container, so inside the digital wrapper, you should have a complete copy of your documentation practice linked to the data. So you say this information object, which is the set of documentation, there was an activity which created it, and that activity used your documentation practice, which is sat in a document, which is also then in the overall container. That gives you the true portability.
Okay. Okay. Thank you.
Pleasure. So thank you very much. I must stop the session. So sorry.
You'll be able to find my email in many places, and if you need to contact me or have questions, very happy to carry that conversation on. I've put I put it only to Gabrielle. My apologies. Control C. Everyone. Control V. There you go. So just hit me, as they say. You can find my email on the SIG. I'm very, very happy to help out.
Yes.